Good afternoon, good afternoon. Today I'm going to go through Preparatory Examination 2025 for Gauteng, Paper 2. The main focus will be on Mapwork, that is Section B. Let's go to Section B. Like I always emphasize, guys, before you start to answer the question for Section B, please make sure you go through the background information. This is for Kroonstad. Okay, let's make sure you go through the background information. Kroonstad is a town in South Africa's Free State province. So already you know the province where you find Kroonstad, and you also know that it's a town. The city is located on the banks of Vaal River, a tributary of Vaal River. Okay, Kroonstad is a bees agriculture and transportation center. It has marshalling yards, grain elevators, engineering works, and vocational and trade schools. The Kroonstad project is a gold exploration project that would potentially become a new Witwatersrand gold field. The project is an estimated gold exploration target of 6.06 million ounces and 62.41 million ounces. Okay. Located 60 kilometers southeast of Kroonstad, Bambanani was an underground gold mine operated by Harmon Gold Mining Company. The mine was closed in 2022 due to increased seismic activity and related risk. Kroonstad railway station serves, and this is situated on the key railway junction that connects Cape Town, Johannesburg, and Bloemfontein. So, boys and girls, this is very important. Whenever you're doing Mapwork, make sure you go through your background information first, because you find that you get some of the answers from the background information. Let's move on to the first question. The scale of the orthophoto map times than the topographical map. You know that an orthophoto map, this is an orthophoto map that we are using, and this is a what? A topographical map. I want to show you something. The bigger the number, the smaller the scale. 1:50,000. The smaller the number, the larger the scale. 1:10,000. The bigger the scale, the bigger the number, the smaller the scale. This is your topographical, which means a small scale map. The smaller the number, the larger the scale. This is your orthophoto map, which means it's a what? Large scale map. So how do we get the answer now? So we are saying now we have got our orthophoto. Then we divide by our topographical. We want to see how many times it is large. So it's 1/10,000 divided by 1/50,000. This is the scale of the orthophoto because we are comparing it to the what? To the topographical map. So what we will do now, the next stage, we'll say 1/10,000 multiplied by 50,000. Remember, we have inverted now. Okay, this is 1/10,000 multiplied by 50,000 over 1. Cancel the zeros. 4, 1, 2, 3, 4. So our answer is 5 what? 5 times. It's 5 times larger. That's how we got the 5 times larger. 5 times larger. So we say 1/10,000 divided by 1/50,000. Then from there, 1/10,000 multiplied by 50,000 over 1, we have 5 times. It's 5 times larger. That's how large the orthophoto is as compared to the topographical map. What I've simply done is, I think you know how you calculate your vertical exaggeration. You are doing a comparison of two scales. That this one 1:10,000 and 1:50,000, which is this one is for the orthophoto map and this one is for the topographical map. That's how I got the 5 times. What is the answer there? Which means it's 5 times larger. That is a large scale map. Okay, let's go to the next one. Due to the influence of the map scale, take note, the features on the topographical map. Remember, we have said that the bigger the number, the smaller the scale. The bigger the number, the smaller the scale. The smaller the number, the larger the scale. So we are saying now the features on the topographical map, okay, due to the influence of small scale, of map scale, the features on the topographical map they are small, 3.1.2. What are they? They are what? We are saying now these features are, that is 3.1.2. 3.1.2. Let me just make sure. It means these features are small okay, and less detailed. Small and less details, which make our answer to be C. Because our orthophoto is for a smaller area, but it's more detailed, which means this explains an orthophoto is for a small area and it's more details. But the features on an orthophoto, they appear to be large and more detailed, which means for an orthophoto, it appears to be more large and more detailed, but for a topographical map it appears to be small and less detailed. Okay, what we are simply saying is something that you did in grade 8 and grade 9, actually from grade 7, where we're comparing a small scale and large scale map. Small scale, we have said that the bigger the number, the smaller the scale. The smaller the number, the larger the scale. So it means a small scale, of course, it is for a bigger area and it's less details. A small scale map, a large scale map is for a small area and is more detailed. You can see what is happening here. You can see what is happening here. This one is for a small area and is more detailed. So the bigger the number, the smaller the scale. The smaller the number, the larger the scale. The bigger the number, the smaller the scale. The smaller the number, the larger the scale. That's what is happening here. Okay. So our answer here is small with less detail, which is C. Kronstadt project produces, guys, come on. What does it produce, guys? What does it produce? Remember, we're talking about gold here. Remember, that's why I was emphasizing that you should always refer to your background information. Produces gold. Kronstadt is a, we have got the answer as well from the background information. Junction, that, Jonex, Cape Town, Johannesburg, and Bloemfontein. So it's in Junction Town. It's in Junction Town. That is your A. Then refer to the topographical map. Refer to the topographical map. Name the feature found with coordinates. Topographical map with coordinates 27, 39, 26, south, and 27. All right, I'm going to do it like this now so that at least you understand what is happening here. 27 degrees, 39 minutes, 26 seconds south, and 27 degrees, 12 minutes, 44 seconds east. All right, let's do it like this. Let's go to our latitude. This is 27, right? And our latitude, the number increase going towards the south. So the degree is still the same, as you can see, 27. What is only changing is the minutes, which means this is 37, this is 38, this is 39, this is 40. That's why we have got 41. That's why we have got 41 minutes here. Same applies with your longitude. We have got 10, this is 11, this is 12, this is 13, this is 14. Remember, these are minutes going toward the east, and that's why we have got 15 here. So the question is saying now, the feature, you've read the topographical map, name the feature found at coordinates 27, 39, 26. All right. So what I usually do is, I have got the degree, I've got the minutes. I've got the degree, I've got the minutes. I also have the seconds. I want to find out the exact feature that is at 26 seconds south. So what I want to do now is, I'm going to take my ruler. There is my ruler. I'm going to measure. I want to have an idea of how long my grid is when it comes to the latitude, which means from there going upwards. So as you can see here, I want to show you something. The length of my grid from here, from the top to the bottom, okay, is around 37. It's around 37 millimeters. Okay, going downward is my latitude. Then going towards the east, which is my longitude. From there, it will give me something like 33 millimeters. So how am I going to calculate this? Okay, I'm going to do it this way. I'm going to take my seconds, 26. I'll say 26 seconds over 60 seconds multiplied by 37 millimeters. Why am I doing this? I want to find out the exact position of the feature. I want to find out the exact position of the feature. Okay, that is on this. Okay, so the first thing is our 27, 36, 37, 38, 39, 40 is 27, 39, which means anything in this range between 39 and 40, that's where my 39 is. Okay, and let me find out now my longitude, which means I'm going towards the east. What do we have? 27, 12, which means this is 11, 12, 13. I'm going to go down, which means the grid that I'm going to work on is this one, is this grid. I'm going to work on this grid, okay? Going downwards. This is the grid that I'm going to work on, going downwards. This is the grid I'm going to work on, going downwards. Okay. So this is the grid because it says 27, 39, 27, okay, 39, 37, 38, 39 up to 40, which means from here up to there. That's where my 39 is. Here up to there, that's where my 39 is in terms of latitude going downwards. In terms of longitude, that's 27, which means I'm starting from here, 12 to 13 to get my 12. Okay, so the first thing that I'm going to do is I'm going to take my seconds, which is 26, which is here. Then I'll say over 60 seconds, I'll multiply by 37. Why am I doing that? Because from here up to there is 37 millimeters. I want to find the exact location. So I'll say 26, which I have there, over 60, 26 over 60 multiplied by 37 millimeters. Why do I get? I'll get 16.0. So it means 16 millimeters, which means I'll measure from here going downwards. I'm going to measure 16 millimeters from here going downwards, which means I'll be somewhere here. I'm just gonna draw it across. Okay, this is where I am. Okay, that is 16 millimeters. I'm going to measure going now towards the east, this direction. What do I have? I've got 44, which means I'm going to use now this 44. 44 seconds over 60 seconds multiplied by, remember I've said that from here up to there, what do I have? I have 33 millimeters. Okay, multiplied by 33 millimeters. What do I get? So I'll say 44 over 60 multiplied by 33. What am I going to get there? I'm going to get 24. So it means I'm going to get 24 millimeters. Okay, I have already measured going downwards and I have got what? I have 16. This is where I've got my 16. So now I'm going to calculate 24 millimeters, which means I'm going to measure from here. I'm going to measure from here going towards the east to get my 24. My 24 will be somewhere here. Let's see where these two meet. Where are they meeting? I've got two things. I've got the ruin, I've got the reservoir. Ruin and the reservoir. You can see here, that is the ruin. I also have the reservoir, which is this. So that's what I have at this point. That's what I have at this point. That is 27 degrees, 39 minutes, 26 seconds south, and 27 degrees, 12 minutes, 44 seconds east. That's what I have. I have a reservoir and a ruin. Those are the two things that I have. Okay, it's more of a reservoir. I would say it's more of a reservoir. You can see with where. So this is 16 going downwards. This is 24 going the other side. So which means I've got the reservoir because the ruin is a little bit down. But so I'll take the reservoir that we have there. Okay, let's move on to the next one. It reads, provide evidence that the orthophoto was taken at 1400 hours. Okay, provide evidence that the orthophoto was taken at 1400 hours. You can see now, let's see, what can we say that it was taken at 1400 hours? Number one, can you check? Of course, the shadows, they are not, the shadows that you find on this, they are very short. The shadows that you find on this, they are very short. You can see they are not that long. You can see with the buildings, we can go where our buildings are. The shadows are very short. You can see these are the buildings, the shadows you can see. These are the buildings, the shadows are very short. So it shows that it was taken around, it was taken before 2. Then what else can we use? The direction of the shadows as well. Direction of the shadows, you can see here the shadows is kind of northwest. You can see the direction of the shadows is in the southwest direction. What else? Shadows lie south and southwest of the features. That's what I've been indicating now. You can see south and southwest of the features. That's what I'm talking about. Check here, check there. That's basically what we are talking about. So that's what substats. Okay, let's move on. Calculate the magnetic declination for 2025. All right, what do we have now? 2025, difference in years, which means here we say 2025 minus what do we have on the map? On the map, which year do we have? We have got 2013. You can see here. We have what? 2013. We have got magnetic declination 19 degrees 54 minutes west of true north, January 2023. So it means we say minus 2013. We say 2025 minus 2013. What do we have? 12 years. Which means we're going to get what? 12 years. Here we get the 12 years. We get a mark for that. Use the annual change of 3 minutes westward. This is the mini annual change, 3 minutes westward that they're talking about. This is what we're going to use. So we want to calculate the total annual change, which means we say the difference in years, which is 12 years. Please make sure you write it in full, multiplied by 3 minutes westward. 12 years multiplied by 3 minutes westward. What do we get? We are going to get 36 minutes westward. Remember, this is still our total change. We don't write it as west of true north, it's just westward. Okay, then our magnetic declination for 2025. What we are going to do is we take the magnetic declination for 2013, which is 19 degrees 54. Okay, so we have got 19 degrees 54 minutes west of true north. Then we add what? 36 minutes westward. So if we add the two, I'm going to add the minutes by themselves so that I separate it with the degree. So I have got 90 degrees here. So if I say 54 minutes plus 36 minutes, 54 minutes plus 36, what do I get? I get 90, which means I've got 90 minutes here, 90 minutes west of true north. But I cannot leave it like that. Why? Because 1 degree is equivalent to 60 minutes and 90 minutes is above 60 minutes. So which means I have to take the degree from the minutes and add it to the 19 degrees, which means here it becomes what? 20 degrees. Then how many minutes are we left with? We are left with 30 minutes west of true north. 30 minutes west of true north. So this is how we do it. So the first thing, 2025 current magnetic declination, you look at the year that is on your map, this one. This is the year that you're going to subtract with. So 2025 minus 2013, you got 12 years. Then from there, you've got your mini annual change, which is 3 minutes westwards. It's also given here. So you multiply your difference in years, which is 12 years, multiplied by 3 minutes westward. Then you get 36 minutes westward, or W. Then here for the magnetic declination for 2025, you are going to add now the magnetic declination that you had in 2013, which is 19 degrees 54 minutes. Then you add 36 minutes westward. What are you going to get? You're going to get 19 degrees 90 minutes west of true north. So since your 1 degree is equivalent to 60 minutes, we cannot leave it like this 90 minutes because it's above 60. We have to take the 60 and add it to 19 as 1 degree. So now it becomes 20 degrees 30 minutes that is left west of true north. That will be your magnetic declination for 2025. Let's move on to the next one. Then the next question now reads map interpretation, where most people struggle with map interpretation. Okay, we are moving on to 3.2. It reads refer to the topographical map. This is our topographical map. As you can see, this is our topographical map. Identify the street pattern marked P in the in block D5. Okay, so when it comes to street pattern, let me just highlight. When it comes to street pattern, I think I've got something that can explain here. Street pattern, you can see here, that's a Eben street pattern. That's another one which is more like semicircle. You can see usually it's close to a hub or a sea. You can see here it can be surrounding something, a market, it can be a water point. You can see what is happening here. Then you can see here, it's more linear. You can see here, it's more star-shaped. As you can see there, this is semicircle. You have got the circular shape. This is the circular shape. Then you have got the semicircle. Then you have got the linear. Then you have got the roughly star-shaped. So basically, this is what they are asking you, what type of a shape it is. So we also have the grid iron. That's another type that we can also have. Let's check from the options that we have. So we are saying that in P in D5, you can see these are the, you can see guys, this is a grid iron. You can see the way it is. These are the grid iron. So that's your P here. It shows the grid iron. It does not show the one that I've shown you, the semicircle, the circular, star-shaped, T-shaped. It's not showing that it's a grid ion. So which means the answer here is what? Grid ion. The dominant economic activity taking place in E3 is classified as, let's go to E3. So E3, where do we have E3 here? We have got E3. What is the dominant there? You can see this one is a little bit tricky, but you can see here we have got more of cultivation, which is primary. Then here industries, which more of manufacturing, that is secondary. So I would take two that is both primary and secondary, because both of them are sharing half. You can see this is where you've got your industrial, which is more manufacturing, secondary. Then this is where you've got your primary, which is more of agriculture or cultivation. So the two are sharing. So when it comes to the economic sector, of course, we are talking about your primary, talking about your secondary, tertiary, and your quaternary. So here there is more of primary. Okay, you can see on the southern part, northern part, there is more of secondary. So both two are sharing, which means both primary and secondary are dominant here. Then discuss one physical factor evident on topographical map that led to the development of nucleated settlement pattern in block A3 and B3. Block A3 and B3. What has resulted in the development of nucleated settlement in block A3 and B3? A3 and B3. A3 and B3. What has led to that? Okay, so you can see generally the land is flat. Why? Because of the contours. The land is flat, flat land, making it easier to construct or farming. It's close to a river, which means there's access to water. You can see with the drainage that is there, of course. So it's generally flat land. It's also, which makes it easier to construct or farming. It's closer to river for access to water as well. So those are the answers. Let's move on. Refer to the row of trees in block R76A2. To the block or rows of trees along R76 in block A2. So A2, this is the R76 that we are referring to. This is the R76 that we are referring to. So we are saying refer to the row of trees along R76 in block A2 on the topographical map. Explain the function of the row of trees. What is the function of this row of trees? What is the function along this road? Number one, they can act as a buffer to protect the cultivated land on either side of the road, on the other side of the road. You can see that there's cultivated land here. So they are acting as a buffer to protect the cultivated land on either side of the road, which means they act as windbreaks. You can also say that. They act as protection for road users from crosswinds. It's a windbreak. They enhance the aesthetic of the road area or space. So those are the answers that you can actually write. Then refer to the topographical map. Refer to the topographical map. Refer to the marked R. Where is my R? Where is my R? Okay, that is your R here. Okay. In block E5 and the area marked Q in block D2. At Q in D2. This is Q in D2. This is Q in D2. R and Q. Q and R. Okay. Provide map evidence to prove that the R is the older development compared to area Q. R is an older development. Let's see what we have. REC. What does REC mean on our key? REC, let's check. Right, what does it mean? Okay, we are still checking. I want to make sure that you understand what is happening here. What do we have? Actually, a road. Okay, I'm still checking. I want to make sure that I get it right. Okay, recreation ground. Okay, that's recreation ground. So what do we have at Q? At Q, this is Q, roads under construction. Okay, provide map evidence to prove that R is the older settlement compared to Q. So Q, we are saying now Q, roads under construction, which suggests that it's new. So Q, there is road still under construction. There is an irregular street pattern in the new pattern. You can see irregular, new, which is a new pattern that we have there. Irregular pattern is also under construction. If you go to R, there is presence of monuments, which indicates old part of the city. We can see the presence of monuments, which of course indicate the old part of the city. Then what we have? We also have grid ion. street pattern in the older pattern. What we have here, the grid iron, remember we once talked about it. This is an older pattern, okay? The old town hall and the leaping fountain, that's another evidence. Here, old town hall and leaping fountain suggests that it is old. Okay, let's move on to 3.2.3. Refer to calculus in block C1. Block C1. What do we have? We are referring to this one. We are referring to this, okay? The question reads, discuss one factor evident on the topographical map limiting the expansion of calculus in the southwesterly direction. Southwesterly direction, which means here, what we have got the presence of marsh and clay. On the western direction, presence of marsh and clay. That's what we have here. So that is your answer there. Let's move on to 3.2.4. 3.2.4. What is 3.2.4 saying now? Provide evidence from the topographical map to support the statement that the industrial is ideally located in E3. E3, where it is here. This is where we have got our industrial. Is it ideally located? What evidence is there to show that? You can see with the road network. You can see with the road network that is there. We can say good road network for easy access to transport and local markets. That is number one. We are looking at this. We are looking at this. Then we can also say railway close by facility for easy transport of goods. You can see what is happening here. We can also say access to labor force available from residential areas that are close by. What else? Gentle slope for easier construction. Remember, this is far away from the CBD where they can actually expand horizontally. It's far from residential areas to minimize pollution, close to raw materials, cheaper land on outskirts, power lines nearby. Those are some of the things that you can actually talk about. Let's move on to 3.3. 3.3. It reads, define the concept attribute data. Attribute data, this is data that describes or gives further information about a feature. This is information data that describes or gives further information about a feature. It is also known as non-spatial data. That is your attribute, okay? That is your attribute. Like the name of the place, your Kronstadt, okay? The contours, of course, for us to know that the contour lines is also part of the attribute. The different names that you have on this map is part of attribute data because it's more descriptive. It gives further information about a feature. It gives further information about spatial data. Okay, that's an attribute. It's more descriptive. Okay, refer to the orthophoto map. Name one way in which attribute data is represented on the orthophoto. The way is in which attribute data is represented on the orthophoto. Obviously, your contour lines, they represent height, of course, on the map. So that's one way in which attribute data is represented on the orthophoto. So you've got your contour line. You also have your spot heights. You also have your spot heights. Of course, on the map, you also have your spot height. That's also another way in which attribute data is represented on the orthophoto. Then the name of places. Name of places, like here we have got Old Town Hall and Leaping Fountain. That's an attribute data also on an orthophoto map. So that's how it is represented. Attribute data is more descriptive. Gives more information about the feature, describes and gives further information. Then the refer. Which one am I doing? Refer to bridge 6 on orthophoto in block E4 on the block E4 on the topographical map. Okay, so this is we are saying now we are referring to 6. Where is 6? 6 is here. You can see there is our 6 here. There is our 6. Okay, which is a bridge. It's indicated. And block E4 on the topographical map. Block E4 on the topographical map. E4 on the topographical map. Okay, block E4 on the topographical map. This is our topographical map. The question is saying, provide one attribute of the bridge evident on the topographical map. 3.3.3. We are now saying that there is Alexander Bridge. Of course, it's name of the bridge. Of course, Alexander Bridge. Okay, what do we have? Okay, Alexander Bridge, that's the first thing. We said I want to make sure that I give you the right thing here. E4, Alexandra Bridge, of course we know that is the name of the bridge. That's part of the attribute. Name of the bridge is given. The height is also given, the height of the bridge. You can see it's given here. 1.3.36, where is it in E4? I want to make sure that you get the correct information here, of course. All right, 1.3, 1.336, I'm checking it, E4. All right, and here what we have got in 6, of course, that is your Alexandra Bridge, name of the bridge. Then here in E4, I want to make sure that we have the correct information. That is your E4. You can see the bridge that is passing through there, okay? That's basically what we are talking about. I think you can see from this topographical map, you can also see the name of the bridge here that is shown. That is your attribute data. Then what else do we have? Then refer to A4 on the topographical map. 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 This is where we are. A4 on the topographical map. What are they saying? Draw symbols of the following features evident in block A4. So your A4 is here. What symbols are evident there on block A4? What can we see in A4? Let's talk about the point first. Let's talk about the point. What can we see at the point? A4, we have got the wind pump. This is the wind pump that we have in A4. Wind pump. Okay, that is a point feature. What else do we have? We also have the ruins. Okay, you can see from what we have, these buildings. Okay, in A4, we also have the ruins. Where am I getting that? You can check here. The ruins. Okay, the ruins, that's what we have here. That's a point as well. Then what else do we have? We also have the buildings. We also have the buildings here. Ruins, then the buildings. That's a point feature as well. Ruins, then the buildings. Then what else do we have? We have got a water source. This is a water source F. That's a point feature that we also have. Okay? Then what else do we have? Let's check what we have here. On this road, what do we have here? Okay. In A4, do we have something else besides what we have shown you? Of course. Let's now check in the line. The line symbols. We have got the contour line, which is this one. That is the contour line. That's a line feature. What else do we have? We have got the roads that are showing there. We also have the farm boundary. We have the farm boundary as well as a line. We also have the row of trees. The row of trees in A4, the row of trees. We also have the trek and hiking trail. Trek and hiking trail, that is also within A4. So these are the features that we have. I think for today, this takes us to the end of our lesson on revision of paper 2 2025 preparatory paper. I have emphasized that we have got the point features. I think I've shown you the point features like you've got here. You've got your wind pump, you've got your ruins, you've got your buildings. What else do you have? Your line, you've got your the farm boundaries, that is your line. You've got the water point, that is your point. Of course, trekking there, that also forms your line. So these are some of the things that you have. I think this has taken us to the end of our paper 2 preparatory for Gauteng. I was only focusing on section B. So please go through this. If you have anything that you do not understand, please you can just comment. Let me know so that I can also do a video on those things that you do not understand, so that you can have a better understanding of Mapwork. Mapwork is very easy, guys. It just needs practice. It just needs practice. It just needs application of concepts. What you have done, like under settlement, what you have done in economic geography, it's a matter of application. Remember, we're talking about the urban street patterns. We're talking about what else did we get there? The issue of land use. So those are some of the things that we did in settlement. We're talking about the economic activities. We did this under economic geography. So it's a matter of application. Now, you take what you have from your different topics, then you apply it to Mapwork. That's simply what we'll be doing. So thank you so much. Goodbye.